Did you know that the average American consumes about 20 pounds of ice cream each year? This creamy, frozen treat has roots tracing back to the 2nd century BC, with mentions of ice and snow mixed with fruits and honey in ancient Greek and Roman writings. However, the version of ice cream we know today started to take shape in the 16th century, evolving from a luxury dessert for the elite to a popular snack available to everyone. The production of ice cream has come a long way since then, with modern technology and scientific understanding enhancing both its quality and variety. So, how is it made? The creation of dairy-based ice cream begins with its core ingredient, milk, usually sourced from dairy farms. The quality of milk is paramount, undergoing strict testing for purity, fat content, and bacterial count to meet high standards. Alongside milk, cream, with a typical fat content of 36 to 40%, is essential for ice cream's rich texture. Sugar, derived from sugarcane or sugar beets, not only sweetens the ice cream, but also lowers its freezing point for a smoother texture. Emulsifiers like egg yolks or soy lecithin ensure a uniform mixture, while stabilizers such as guar gum or carrageenan prevent ice crystal formation. Flavorings are diverse, ranging from natural vanilla extracts to cocoa powder for chocolate-flavored varieties. Pureed fruits are also used for fruit-flavored ice creams, with a focus on quality and authenticity in taste. Additionally, chocolate in various forms plays a significant role, especially in chocolate-dipped ice cream varieties, where ice cream bars are enrobed in a rich chocolate coating, adding a delightful contrast in texture and flavor. Inclusions such as nuts, chocolate chips, and caramel swirls are sourced from specialized suppliers, adding texture and complexity to the final product. These ingredients are carefully selected for their quality and consistency, ensuring each batch of ice cream meets the desired standards of excellence. The journey of transforming raw materials into delicious ice cream begins with the pasteurization of milk and cream. This crucial step involves heating the mixture to a specific temperature, typically around 155 to 175 degrees Fahrenheit, or 68 to 79 degrees Celsius, for a short period. This process not only kills harmful bacteria, but also stabilizes the fat emulsions, enhancing the mixture's ability to hold air and create a smoother texture. Following pasteurization, the mixture is homogenized, a process where it is forced under high pressure through small openings. This breaks down fat molecules to a uniform size, preventing them from separating and rising to the surface. Homogenization contributes significantly to the creamy and consistent texture of ice cream. Next, the sweetening stage begins, where sugar, along with any liquid flavorings like vanilla extract or chocolate syrup, is added. This is followed by the incorporation of stabilizers and emulsifiers, ensuring an even distribution throughout the mixture. For chocolate-flavored ice creams specifically, cocoa powder is blended in at this stage, giving it the rich chocolatey essence. The mixture is then cooled rapidly to around 40 degrees Fahrenheit, 4 degrees Celsius, to halt any microbial growth. This cooling phase also allows the flavors to meld together harmoniously. The blend is allowed to age for several hours or overnight, which further improves its whipping qualities and overall texture. For fruit-flavored ice creams, fruit purees or chunks are prepared separately. These are typically mixed in after the initial cooling stage to preserve their fresh flavors and textures. Similarly, inclusions like nuts or chocolate chips are also kept aside to be added during the later stages of the freezing process to maintain their integrity. With the base mixture now prepared, homogenized, flavored, and cooled, it's ready to move to the heart of ice cream production, the freezing process. The main manufacturing process of ice cream is a fascinating blend of science and artistry, where the prepared base mixture transforms into the creamy dessert we all love. This phase begins with the freezing process, which is crucial in achieving the desired texture and consistency. Freezing is carried out in specialized machines called continuous freezers. Here, the ice cream mix is rapidly frozen while being simultaneously churned. This churning introduces air into the mix, a process known as overrun, which can range from 25 to 100% of the mix's volume, depending on the desired density and creaminess. The inclusion of air is essential. It prevents ice cream from becoming a solid ice block, instead giving it a light, soft texture. As the mixture cools, ice crystals begin to form. The size of these crystals is pivotal to the quality of the ice cream. Smaller crystals result in a smoother texture, while larger crystals can make the ice cream grainy. The rapid freezing and constant agitation in the freezer ensure these crystals remain tiny. For chocolate-flavored ice creams, the process includes an additional step where the mixture is enriched with chocolate liquor or cocoa powder to enhance the chocolatey essence. For varieties destined to be chocolate-coated, the frozen ice cream bars are dipped in melted chocolate, creating a hard, crisp chocolate shell. This dipping not only adds a delectable flavor contrast, but also an appealing texture difference. Throughout the freezing process, temperature and texture are closely monitored. The mixture exits the freezer at around 22 degrees Fahrenheit, minus 5.5 degrees Celsius, with a soft serve consistency. It is then quickly transferred to a hardening room, where temperatures are significantly lower, around minus 30 to minus 40 degrees Fahrenheit, minus 34 to minus 40 degrees Celsius. This rapid hardening process prevents the growth of large ice crystals and ensures the ice cream maintains its smooth texture. In the case of fruit-flavored ice creams, the fruit purees or pieces are added during the latter stages of freezing. This timing is critical to prevent the fruits from becoming too hard and to ensure they are evenly distributed throughout the ice cream. Likewise, inclusions like nuts, cookie pieces, or chocolate chips are added at this stage, ensuring they retain their texture and are uniformly mixed. After the hardening phase, the ice cream is almost ready for consumption. However, for certain products, there are additional steps. For instance, ice cream destined for cones is deposited into cones and then flash frozen. Multi-flavor ice creams require a layering process, where different flavors are carefully added in layers and then frozen. For ice creams with ripple effects, such as caramel or fruit syrups, the syrup is injected into the ice cream during the packaging process, creating a marbled or rippled effect. This technique requires precise timing and control to ensure the syrup is evenly distributed without overly disrupting the ice cream structure. The final stage in ice cream production is packaging, a process that plays a crucial role in maintaining the product's quality and integrity during transport and storage. Packaging is tailored to the specific type of ice cream. For tubs or cartons, the ice cream is piped into containers, often under a controlled nitrogen atmosphere, to prevent ice crystallization and freezer burn. This method also extends shelf life by reducing oxidation. For individually wrapped products like ice cream bars or sandwiches, each item is swiftly wrapped in a moisture-resistant material, ensuring the product remains dry and its quality is preserved. The packaging material often includes layers of foil and plastic to prevent exposure to air and light, which can degrade the flavor and color of the ice cream. Once packaged, the products are stored in freezers at temperatures below minus 20 degrees Fahrenheit, minus 29 degrees Celsius, to preserve their texture and prevent melting. This careful packaging process ensures that the ice cream reaches consumers in the best possible condition, retaining its flavor, texture, and overall quality.